Hello students, what is going on? My name is Abdullah Momin from KMES English Medium High School and Junior College, and this is your lecture number 6 from the chapter Oscillation from class 12 syllabus. And in this video we are going to study about the composition of two SHMs. So the very first thing which we are going to see is the equation of resultant SHM. We are going to derive the equation of resultant SHM, and then we will find out the equation of amplitude of resultant SHM and initial phase of resultant SHM, and then we are going to see the three special cases of phase difference. So first, composition of two SHM having same period and along the same path. To consider a particle subjected simultaneously to two SHMs having the same period and along the same path, let it be along the x-axis, but of different amplitudes and initial phases. तो दो SHM को कंबाइन करना है और वो दो SHM का एम्पलीट्यूड डिफरेंट है और इनिशियल फेजेस डिफरेंट है. तो फर्स्ट SHM के लिए हम इक्वेशन लिखेंगे x1 is equal to a1 sin omega t plus phi 1, where a1 is the amplitude of the first SHM and phi 1 is the initial phase of the first SHM. Similarly, for second SHM, we will write x2 is equal to a2 sin omega t plus phi 2. So the resultant displacement at any instant is equal to the vector sum of its displacement due to the both SHMs at that instant. So we are going to add x1 and x2 in order to get the resultant SHM. So instead of x1, we are going to put the equation of x1, and instead of x2, we will put the equation of x2, and then the equation of x can be written as x is equal to a1 sine omega t plus phi 1 plus a2 sine omega t plus phi 2. And now we are going to use this formula to expand this term, that is sine a plus b is equal to sine a cos b plus cos a sine b. So we are going to expand the term sine omega t plus phi 1. So it can be expanded as by using the above formula as sin omega t cos phi 1 plus cos omega t sin phi 1. Similarly, sin omega t plus phi 2 can be written as sin omega t cos phi 2 plus cos omega t sin phi 2. Now we are going to put these terms in the given equation of x. So x can be written as a1 sin omega t cos phi 1 plus cos omega t sin phi 1 plus a2 in bracket sin omega t into cos phi 2 plus cos omega t into sin phi 2. Now multiplying a1 to the bracket and a2 to the bracket, or we are going to open this bracket, and now we have x is equal to a1 sin omega t into cos phi 1 plus a1 cos omega t into sin phi 1 plus a2 sin omega t into cos phi 2 plus a2 cos omega t into sin phi 2. Now we will rearrange this term a1 sin omega t dot cos phi 1 plus a2 sin omega t into cos phi 2 plus a1 cos omega t into sin phi 1 plus a2 cos omega t into sin phi 2. Now we will take sin omega t common from the first two terms, and from the last two terms cos omega t can be taken as common. So this equation of x can be written as x is equal to a1 cos phi 1 plus a2 cos phi 2 sin omega t plus a1 sin phi 1 plus a2 sin phi 2 into cos omega t. As a1, a2, phi 1 and phi 2 are constant, we can combine them in terms of another constant, that is r and delta. So we can write r cos delta as a1 cos phi 1 plus a2 cos phi 2. This is your equation number 1. and r sine delta is equal to a1 sine phi 1 plus a2 sine phi 2. So x can be written as r cos delta into sine omega t plus r sine delta into cos omega t. Now r is taken as common, and in bracket we will get sine omega t into cos delta plus cos omega t into sine delta, and this is the formula of sine a plus b. So you can write x is equal to r sine omega t plus delta, and this is the equation of resultant SHM, and in this equation r is the resultant amplitude and delta is the initial phase. So now we are going to derive the equation of resultant amplitude r. So by using equation 1, which is r sine delta is equal to a1 sine phi 1 plus a2 sine phi 2, and r cos delta is equal to a1 cos phi 1 plus a2 cos phi 2. These equations we have taken from the previous slide, and now squaring and adding the above equations. So by squaring them, when we will square equation number 1, it can be written as r square sine square delta is equal to a1 square sine square phi 1 plus a2 square sine square phi 2 plus 2a1 sine phi 1 into a2 sine phi 2. Similarly, we are going to square the equation number 2 also, and it can be written as r square cos square delta is equal to a1 square cos square phi 1 plus a2 square cos square phi 2 plus 2a1 cos phi 1 into a2 cos phi 2. Now we are going to add these two equation, and we will get r square sine square delta plus r square cos square delta is equal to a1 square sine square phi 1 plus a2 square sine square phi 2 plus 2a1 sine phi 1 into a2 cos sine phi 2 plus a1 square cos square phi 1 plus a2 square cos square phi 2 plus 2a1 cos phi 1 into a2 cos phi 2. Now r from the left hand side of the equation is taken as common, and we will write r square sine square delta plus cos square delta is equal to a1 square is taken common, we will get sine square phi 1 plus cos square phi 2 plus a2 sine square phi 2 plus cos square phi 2 plus 2a1 a2 sine phi 1 sine phi 2 plus cos phi 1 cos phi 2. So r square sine square delta plus cos square delta is equal to a1 square sine square phi 1 plus a2 square cos square phi 1 plus a2 square sine square phi 2 plus cos square phi 2 plus 2a1 a2 sine phi 1 phi 2 plus cos phi 1 cos phi 2. Now this is your trigonometric identity. So instead of sine square delta plus cos square delta, we will put 1. Instead of sine square phi 1 plus cos square phi 1, we will put 1. And instead of sine square phi 2 plus cos square phi 2 is 1. So we will get r square a1 square plus a2 square plus 2a1 a2 sine phi 1 sine phi 2 plus cos phi 1 cos phi 2. We have the formula cos phi 1 minus cos phi 2 is equal to sine phi 1 into sine phi 2 plus cos phi 1 cos phi 2. So we will get the equation r square as r1 square plus a1 square plus a2 square plus 2a1 a2 cos phi 1 minus. So r can be written as root of a1 square plus a2 square plus 2a1 a2 cos phi 1 minus phi 2. So this is the equation of resultant SHM. Now we are going to derive the equation of initial phases. So we will divide equation number 1 and 2, which is r sine delta a1 sine phi 1 plus a2 sine phi 2. This is your equation number 1. We are going to divide this equation by equation 2, that is r cos delta is equal to a1 cos phi 1 plus a2 cos phi 2, and by dividing these two equation, r will get cancelled. Sin delta upon cos delta become tan delta. So we will write tan delta is equal to a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. And when we will take then another side of the equation, it will become inverse. So delta is equal to tan inverse a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. So this is the equation of resultant phase. Now we are going to see the three special cases one by one. First case is if the two SHM are in phase, that means the phase is equal, and when we will subtract the equal terms we will get 0. So if phi 1 and phi 2 are equal, then phi 1 minus phi 2 is 0, and cos 0 can be written as 1. So we are going to put cos phi 1 minus cos phi 2 1 in the this equation of r is equal to a1 square plus a2 square plus 2a1 a2 cos phi 1 minus phi 2, and cos phi 1 minus phi 2 is 1. So we will write r is equal to root of a1 square plus a2 square plus 2a1 a2, and this is the formula of a1 plus a2 whole square. Square and root get cancelled, and we will get r is equal to a1 plus a2. Now if their amplitudes are equal, then a1 is equal to a2 is equal to a. So we will write r as a plus a, that means 2a. Now second case, if the two SHMs are 90 degree out of phase, that means the phase difference is 90 degree, means phi 1 minus phi 2 is 90 degree and cos 90 is 0. So we are going to put the value of cos phi 1 minus cos phi 2 as 0 in this equation of r, which is r is equal to root a1 square plus a2 square plus 2a1 a2 cos phi 1 minus phi 2. And instead of cos phi 1 minus phi 2, we will put 0, so the whole term becomes 0, and we will get r is equal to a1 square plus a2 square under root. And if their amplitudes are equal, that means a square plus a square 2a square, and square and root get cancelled, so a can be taken outside the root and we will get r as root 2a. Now case 3, if the two SHMs are 180 degree out of phase, that means the phase difference, that is phi 1 minus phi 2 is 180 degree and cos 180 is minus 1. So instead of cos phi 1 minus phi 2, we are going to put minus 1, and we will get a1 square plus a2 square minus 2a1 a2. And this is the formula of a1 minus a2 whole square. Cancelling root and square, we will get r as a1 minus a2. And if their amplitudes are equal, that means the resultant amplitude is 0. So thank you student, thank you very much. I will catch you next time.